Hi everyone, my name is Katharina Kann and I'm a computer science professor at CU Boulder. I'm happy to talk to you a bit about my research area, natural language processing. Let's get started. First of all, the basics. What is natural language processing? The goal of natural language processing is to build machines that can perform useful and interesting tasks involving human language. So the natural and natural language processing means that we look at human languages such as Chinese, English, Spanish, and not at, for example, programming languages. So why would we want computers to understand or potentially produce human language? There are multiple reasons for this. First, enormous amounts of text are available in machine-readable forms. We have online newspapers, we have a lot of pages in the internet, medical records are usually digital, financial filings, product reviews, discussion forums, and so on. So we have a huge source of knowledge that we can potentially use. Second, advances in speech recognition make conversational agents a key form of human-machine interaction. But in order to make this possible, we need to process language, to understand language, generate language. Third, much of human-human interaction is now mediated by computers via social media. So, this gives us the chance to, for example, automatically detect fake news, right? So maybe someone is telling their friends something that just isn't true and that they found somewhere, and we could potentially flag this as, hey, you should check this information. Or we could automatically detect hate speech, implement warnings, and so on. So I want to talk to you now about some typical natural language processing tasks, just to give you a better idea of what we're really talking about. Probably the most popular task is machine translation. And I think it's pretty obvious what this is. So it's just a machine translating as opposed to a human translating, but the task is really the same. So the input is always a sentence in a so-called source language, and the output is supposed to be kind of the same sentence, so a sentence with a very close meaning in a target language. For instance, this could be given a sentence in English, translate the sentence into a sentence in German. So here we have an example. He saw a red bicycle, and the translation would be, sah ein rotes Fahrrad. Another popular NLP task is sentiment analysis. So here the goal is given some sort of text. So this could be a sentence, could be a short document, could be a tweet. Output the sentiment, like the feeling expressed by this piece of text. And how exactly the output should look like depends on probably the final application. So this could be very basic. So either positive or negative. So a positive, negative feeling, or it could be a bit more detailed. So it could be positive, negative, or neutral. Or if you're really interested in nuances, it could be a score from like 1 to 10. And here's an example. So this is a tweet I totally made up. Don't use Uber, you may not reach your destination. So I think it's clear that this is expressing a very negative sentiment. So someone apparently had an unhappy experience using Uber. Or, for example, another tweet, I will always love the soundtrack of Tarzan. So this is clearly positive, right? Someone's really a fan of this music. And what you can also see here in those like made up tweets is that there can be all sorts of challenges when solving this task. For instance, if you look at tweets, there could be spelling mistakes. So here, soundtrack is misspelled, right? So the last two characters are wrong. So you would kind of need to account for this. Also, there are 2 exclamation marks at the end, so you might want to normalize this. Tarzan would ideally be capitalized, etc. So sentiment analysis, especially on tweets, and in general NLP involving like text from social media requires to look at this. Another popular task is question answering. As the name is saying, the goal is, given a question, find the answer. More formally, the input could be either the question or optionally also the question with answer choices. So this would be a multiple choice question. And then the output should be the answer in some form. So for a multiple choice question, this could be just a classification. So saying it's answer 1, answer 2, answer 3, answer 4, and so on. Or it could be a short or like long answer. So here we have an example. How many moons does Earth have? And the answer is just 1. So this is clearly a short answer. But the answer could also be longer and, like, for example, state something like, why Earth has like 1 moon, but other planets might have more, like something like that. So some additional background or potentially like a justification for the answer. Yeah, and of course there are many other NLP tasks. So I'm just going to show you a quick overview. This is by no means an exhaustive list. So for instance, there is automatic summarization. Given a longer piece of text, for example, a website or maybe a book, write a short summary. Then there's like dialogue. So yeah, this is everything like around Siri, Alexa. And then there are more basic tasks. So like part of speech tagging refers to assigning a category to each word, like noun, verb, adjective, etc. Parsing is concerned with the syntactic structure of a sentence. And so on. Since I'm just giving you a very high-level overview, I'm not going to talk in detail about any machine learning algorithms or models that we're using. However, I imagine that some of you probably have some experience with machine learning, so I want to drop some keywords to give you a rough idea of what you could apply to an NLP problem. So you could use basic things like k-nearest neighbors. You could use hidden Markov models, logistic regression, and recently deep learning has kind of been taking over NLP. So something you now see very frequently are feed-forward networks, recurrent neural networks, transformers, convolutional neural networks, and so on. Something else I want to mention is, where does the data that we use come from? So this, of course, depends on the task you're interested in and the language you're interested in. However, something that's frequently used is, for example, Wikipedia, or also data from Twitter, data from Facebook, and like similar sources. However, coverage of those sources is limited. Wikipedia by far doesn't cover all 7,000 languages in the world. There are some resources that are smaller but have a larger coverage, such as Watchtower translations, Bible translations. And then, of course, for certain tasks, you need like specific data. For instance, for machine translation, you would need parallel data. So then you could think about, where do I get parallel data from kind of for free? And examples include movie subtitles. So someone has already translated those, right? We can just leverage them to train machine learning models. Another good source for machine translation data are multilingual parliament proceedings. So parliament proceedings that have been translated into multiple languages already. Okay, finally, I want to tell you a little bit of what I specifically work on. So in my group, we currently work mostly on 3 main areas. The first area is what I call universal NLP. And the main question here is really, how can we create NLP systems for all of the world's languages? Second, we're concerned with, how can we use NLP for education? So how can NLP help teachers and students or just make learning more efficient? Finally, we're focusing on language grounding. And the question here is, how can we make computers connect language to real-world experiences? So just looking at text, machine learning models can and do, in fact, figure out that something like apple is similar to something like, let's say, banana or peach. However, if we were to connect them to some sort of camera and show them an apple, they would never know that this is, in fact, the apple. So we kind of want to close this gap. So with regards to universal NLP, one thing that we are interested in are like multilingual neural models, such as multilingual BERT. So if you have heard about BERT, that's a large pre-trained model that has really improved the state of the art in natural language processing in a bunch of tasks. So how those models are usually trained is in kind of like two stages. So the first stage, the model is pre-trained on a large amount of unlabeled text. So we expect that in this phase, it learns some general properties of language. So for example, like that an apple is similar to banana. And then there's the second phase called fine-tuning, in which the model is trained on a small amount of labeled target task data. So if you're interested in sentiment analysis, like you want to know if a certain tweet is positive or negative, you might want to train the model at this point on tweets that are labeled as positive or negative. So something we're looking at in my group is, assuming we have a multilingual pre-trained model, so it has seen a lot of unlabeled text in like maybe 100 different languages, how can we adapt this to be applicable to a language that it has not seen during pre-training? So potentially a language which has very limited, even unlabeled data. Yeah, and let me also give you an example for NLP for education. So something we're currently working on is a system we call the AI partner. And the goal of the system is to encourage students to have productive small group discussions. Why is this useful? Because it has been shown that students, or like for example high school students in a class, learn much better if they're discussing a topic than when they're just listening to what a teacher has to say or is telling them. So then you could say, okay, that's great. Let's have the students have discussions among themselves. So let's assume you have a class with like 30 people. You could split this class into like 6 groups of 5 people. But then, however, you still only have one teacher. So the teacher can only help students in one group, or needs to switch between groups and potentially misses out on like one group being stuck and so on. So what we really want to have is a system that can kind of like attend those small group discussions and potentially help students to be more productive. So maybe like in the group, everyone's tired, nobody really wants to talk. And then the system can kind of like motivate them and be like, hey, what do you think about like this thing we've been discussing? Of course, building such a system is highly complex. So there are a lot of research questions that we're trying to answer. So for instance, how can we automatically detect if the student's discussion is off topic? So maybe they were supposed to discuss, I don't know, evolution, but are discussing Star Wars instead. So in that case, we might want to know that to then kind of like guide them back to the original topic. And then how can we generate utterances that can guide the conversation? So ideally, we don't want to have like, I don't know, only 10 different utterances and pick like one of those, but we want to generate them to be more like suitable for the current context or potentially the current students. Last, I'm going to talk to you about our work on language grounding. One project we're currently working on is concerned with the fact that most NLP models have a strange understanding of colors. So this means just that they don't know what's the typical color of a given object. And this is due to reporting bias. We, as humans, don't usually state the obvious. Just think about how often do you tell your friends, do you want a yellow banana? Probably never, because you just assume your friends know that the banana you're offering is yellow, right? So what we're looking at is, can we train deep learning models on text in combination with other modalities like images, such that they have a better understanding of colors? Okay, so that's it from me. If anything I'm working on, or more generally NLP, seems like something you might want to explore more, feel free to check out my website and enjoy this course.